Hi, welcome. We are going to dive into the world of Rust programming language and explore the key differences between expressions and statements today. We'll cover each of them in detail and then see how they are used in your code. Whether you're a beginner or an experienced Rust developer, this video will provide valuable insights and help you write better and more efficient code. So sit back, grab a cup of coffee, and let's get started. So first of all, the simplest explanation is this. Rust is an expression-based language. What it means is that almost everything in Rust returns a value. Okay, even when you have something that doesn't really return anything, it actually returns something. So let me give you a very quick example before I get into the explanations. Let's say you have a variable, okay, and you called it days, and then you set it to 7. Now this variable is of type i32 and it's initialized to 7. So what happens here is, what it means is we've bind days to the value 7. Now a few things you have to understand here is this. 7 on its own is an expression simply because it returns a value, and whatever it returns is what we stored inside this. And you can see that if you print that to the terminal, we get days equal to 7. So what it means is that we've succeeded in putting 7 inside days. Now 7 is an expression, that is why it was able to return a value. And then however, for a statement, a statement doesn't return any value. So I can demonstrate that by creating another variable called a, and I try to assign whatever this will return inside here. It will not allow it because it doesn't return anything at all. Also, a function declaration in Rust is a statement. It doesn't return any value. So we can try to define a function inside here, and let's call it just a function, okay? And then when we save it, it will not return any value since it is a statement. So we can't technically do something like this. Now another thing you have to understand is that there are two types of statements in Rust: a declarative statement and also a let statement. We've already seen the let statement when you create a variable, okay, and then assign a value to it. So this is one type of statement in Rust. It is called a declarative statement, a let statement. However, a declarative statement is when you create an item, when you declare an item, okay, and an item could be maybe a function, a struct, or even a const is an item. So if we do something like this, if you say today, and then we assign it to Friday, for example, okay, and then we give it a type. So here technically we've created an item. So the let statement is one type of kind of statement in Rust, while a const declaration or a function declaration is also a type of statement in Rust. They don't return any value. Now if you came from other object-oriented programming languages, say Java for example, you should know the type void, okay? When you don't want a function or a method to return anything, you indicate that by saying it's going to return a void. Rust have something called unit, okay, and let me show you. Let's say we have a function here that adds 2 numbers, okay, or let's say it adds 2 numbers and returns the value. Now watch what happens. Right now we did not define the type of value this add function is going to return. But however, under the hood, what Rust did is to set the return type for this variable as a unit. So a unit in Rust is represented by this. It is just a single value, okay? This represents a unit in Rust. So like what you would do in other languages by specifying void here to indicate that the function add will not return anything. In Rust, you use a unit to indicate that this function will not return anything. Now watch what will happen when we did not provide it. Let's say we came in here and then say that this function will return 7, for example. Okay. You see that Rust will start warning us, and it will say expected a unit. So it was expecting this, but it found an integer. So you are trying to return an int, while you did not say it will return an integer, which means under the hood it was expecting something like this. So if you want to return anything from a function, you must provide the type here. If not, Rust will automatically use a unit, like providing void. Now, another thing that is very interesting in Rust is this. If statements are also expressions, they can return a value, and I'm going to show you exactly what will happen here. And there is also another issue that you might run into that I'm going to explain. Let's say we have a variable here that we'll call a boolean. Let's say it is called is Friday. And then we set it to true, so it will be a type boolean. Okay, and then we come in here and then say let today equal to. But we want to know if today is Friday before we assign the type, before we assign whatever we want to print to the terminal over here. So what we can do is we use an if statement. So whatever the if statement will return is what we are going to install in today. So what we can do here is we say if is Friday. Okay, and then in here we return Friday. So let me unpack this right quick. Else, I'm going to show you why it's giving us that error now. Now, when we run this code, we find out that today will hold Friday because Friday variable here is set to true. In fact, let me show you. If I run this code, you see that it says today is equal to Friday. So we've managed to assign what we have in when we returned in the if statement inside this variable called today. And let me unpack this right quick. First of all, we created a variable called today, and then we say it's going to be of type strange. I'm going to explain why we had to use this sign and sign here in another video. Okay, but it's necessary if we want to use this primitive type strange in this case. And then on the right hand side, we've assigned everything that the if statement returns to this, which means the if statement, this if expression is actually an expression because it returns a value. So don't mind me, I keep calling it a statement, but it's actually an expression. It means it returns a value that we can store in here. And then inside here, you can see that we did not use any return statement. And that is because this is the last part of this block of code. Therefore, you can just type it in and then it will be returned. But the problem is if you use a semicolon here, it will no longer work because it will no longer see it as a return value. So if you want to use a semicolon, then you have to specifically use the word return. So here we've specified that this will return Friday, and that was why we were able to store Friday inside today. But earlier on, you found out that we got an error. If I remove this else part and then we have only if statement, Rust will start panicking. Okay, to say if may be missing an else clause. What it simply means is that if you have an if expression, it does not have an else part. It will never return whatever you want it to return here. It will just return a unit. And that is because it will try to return a unit. You can see it over here. So if you want to use whatever is returned inside an if statement, you must provide the else part of it. Okay, that is one of the rules you have to follow in order to achieve this. Now let's take a look at another example with the loop statement. If you want to know how the loop statement works, check out this video that I made earlier explaining in detail how the loop statement works in Rust. So let's say we create a variable and then we call it a. We can return whatever the loop expression returns and then assign it inside a. Okay, right now it's not returning anything, but we can make it return something. Let's say, and you understand that a loop statement will loop forever, so we need to somehow stop it and then return something from it. You can easily do that by using the break keyword and then specifying what we want it to return. In this case, it will return a 65. And if we print that to the terminal, we'll get a is equal to 65. You can see that we've managed to assign whatever this loop returns inside a, and then we were able to print it here. So loop, that goes to prove that loop is also an expression because it was able to return a value that we assign inside a.